Hi, it's Kevin Lebates here, and today I want to talk about the concept of control and access in development. Now, this actually stems a bit from the concepts of ownership and of possession, and those are legal terms, and they make common sense when you're talking about real physical possessions. So, for example, I own something if the law recognizes that it belongs to me and not other people. Whereas I possess something if I have it on me and I can prevent other people from having access to it. When you start getting to abstract concepts, such as intellectual property, then ownership and possession gets a bit trickier, because it's not very clear if you are the, for example, inventor of something and you have a patent for it, exactly where that invention is. There's not a physical object that you can grab and say, I now have it in my possession. And what's more, you definitely require the courts and some kind of national jurisdiction for your ownership to be recognized. So when we go into development, we throw all that stuff aside. It's not really a concern of ours. What we're talking about is, do you have access to some data, and do you have the right to change that data? And is this right something that other people in general don't have? And then for a developer, it gets a lot clearer. So if you take digital assets on a blockchain, for example, your ownership of some Bitcoin, from a developer's perspective, is pretty simple. You have a private key from which a public key is derived, from which a blockchain address is derived. And if the digital ledger out there, the distributed ledger that is Bitcoin, shows that there are some Bitcoins registered against that blockchain address, then you, as the only person with the private key, are the only person who can sign transactions to transfer that balance to somebody else. So you have the control over that balance and not somebody else. And from an engineering perspective, that therefore means that you have ownership of those Bitcoins. And here's the interesting thing. We're talking here about a system where the access and control is handled in a decentralized manner. There are plenty of centralized ledgers or databases out there where you may be the person who has control over a digital asset, but that control is predicated on the authority or the administration that oversees that ledger giving you permission to make the changes. So if we take something like domain names, for example, the domain names are managed by internet registrars, and if you buy a domain name, then you are relying on one of those registrars to allow you to update the DNS records for that domain. And that's a different kind of access and control than you have in blockchain, where you're not relying on any individual institution out there giving you that control. It is the peer-to-peer network that as a whole recognizes the validity of your transactions and that records them, and that then affects the change. Now, one of the things that I find particularly interesting at the moment is the intersection between this centralized access and control versus the decentralized access and control of blockchains such as Bitcoin or Ethereum, which allow you to kind of tie things together between the Web2 world and the Web3 world. So anybody can create a blockchain address. That's the beauty of it being open and permissionless. You can also go and pay to register assets in the Web2 world, for example, domain names, and then you can start recording data about those two things that prove that you have control over both. So if we take domain names, for example, one of the techniques that Web2 uses to verify that you have control over a particular domain name is for you to put a text string in a web page for that domain name, or the same text string in a text record for the domain name. And Google, for example, uses this to verify that you actually own a domain. And what you can put in there, of course, is a blockchain address. And similarly, on the blockchain, you can put a record with your domain name as data, as a payload for a transaction that you make, and you're sending that transaction from, or rather you're authorizing that transaction using a private key from which that blockchain address is derived. And these kind of techniques allow you to cross-link things. And it turns out that's quite a powerful concept. But as this video has been running for quite a while, I think I'll wrap it up there. Just some food for thought for some of the engineers out there. Give it a look. You may find that you come up with some interesting ideas. I hope you found this interesting, and I'll see you in the next video soon. Bye for now.